Hey y'all, in this lesson we are looking at arithmetic sequences. We want to be able to say, I can understand and represent arithmetic sequences. Our essential question, highlighted in yellow, is, how are arithmetic sequences related to linear functions? We have a couple of vocabulary terms we want to define. So a sequence. A sequence is a list of numbers that often forms a pattern. A term. Each number in a sequence is a term. An arithmetic sequence. When the terms of a sequence differ by the same non-zero number we call d, this sequence is an arithmetic sequence. And common difference. Common difference is the non-zero number that the sequence differs by. This is the d that we refer to. Let's look at our first example, identifying arithmetic sequences. Here we have a table representing times from 1 to 8 seconds and distances from 0.2 miles to 1.6 miles. If we look from each term to the next, looking at those distances, we see that they are each increasing by 0.2 miles. This is what tells us that the distances in this table form an arithmetic sequence, where they have a common difference of 0.2, since we are adding 0.2 each time. Looking at another example, determine whether the sequence appears to be an arithmetic sequence. If so, find the common difference in the next three terms: -4, -2, 1, and 5. Again, we want to look from one term to the next and figure out how much is it changing by and if that's the same amount. From -4 to -2, that's an increase of 2. From -2 to 1, that's an increase of 3. And from 1 to 5, that's an increase of 4. These numbers are not all the same, so there is no common difference, and this series of numbers is not arithmetic. You try. Same thing. Determine if they are arithmetic, and if they are, find the common difference and the next three terms. Try this one on your own. Pause the video while you try this one on your own, and then press play to see my answer. In this problem, as we go from one number to the next, we see that we are decreasing by 3. Each one is decreasing by 3, so we will say that the common difference here is -3. Because the common difference is -3, we can find the next three terms by continuing to subtract 3. The next three terms will be -8, -11, and -14. Arithmetic sequences are linear because they are changing by a constant amount. They can be represented by an equation in the form of y equals mx plus b. So that's your slope-intercept form. The slope, or m, is going to be the common difference. The y-intercept, or b, is going to be the first term minus the common difference. The term number, or the position in the sequence, like first position, second position, third position, this is going to be our input of our function, and the term itself is the output. So that's how we can write an equation. We have an input and an output. Please make sure you've copied down the correct information from this slide before moving on. In this example, we are going to look at how to write a function rule or equation from a sequence. We need to determine what does the sequence start with, what is the common difference, what is the slope, the y-intercept, and finally write our equation. Here we can see the numbers listed in red are just our position, first, second, third, fourth, and so on. The numbers in blue are our actual terms. One of the other ways we can write first, second, third term is by saying a sub 1, a sub 2, a sub 3. In other words, a sub 4 is saying the fourth term in the sequence. So that's what that last little bit underneath there. You don't need to super worry about that right now. We can see that this sequence is starting with the number 3. We can also see 3 to 5, 5 to 7, 7 to 9, Each of these increases is an increase of 2. So our common difference is 2. The slope is the same as the common difference, so our slope is 2. The y-intercept is our first number minus the common difference, so 3 minus 2, which is 1. This means that our equation is y equals 2x plus 1. So you just need the starting number and the common difference in order to figure out the equation that represents this rule. This means that I can now say the 100th number in this sequence, I would take 100 times 2 plus 1. So the 100th number in this sequence is 201. And I don't have to list out all 100 numbers. You try. Here's another arithmetic sequence: 3, 7, 11, 15. Figure out the common difference and use that as well as the other pieces of information to write an equation. Try this on your own by pausing the video, then press play to see the answer. For this problem, we also have a starting amount of 3, but we are increasing by 4 each time. So we're going to have y equals 4x, and then 3 minus 4 is negative 1. So we end our equation with minus 1. Y equals 4x minus 1. To summarize, an arithmetic sequence is a sequence of numbers that follows a pattern. The pattern is that the difference between the two consecutive terms, one right after the other, is a constant number called the common difference. We'll use the form of y equals mx plus b in order to write an equation to represent an arithmetic sequence where m is going to be the common difference and b is the first term minus the common difference. Please make sure to fill in the blanks of your notes so that you have this summary complete. Your next steps are to submit your 7.4 notes, complete your 7.4 practice found in your packet, not on Schoology, then submit a photo of that to Schoology, and then take your 7.4 mastery check. Good luck, and I'll see you in the next lesson.